guys. Oh man, it's been so long since I've done a stream here. Jeez. As well. Formula 1 Grand Prix Australia 2026. What? 2026? The tickets for pre-sale tickets to next year's. This year's. No. They're not really selling too well then. Those pre-sale tickets. I don't get it. Maybe you're out. This is the 2026 one. Don't get it. Right. Let's get started on the stream. Welcome to the screen share. Screen too slow. Oh, let's get back to it. So what were we doing? Getting into CarPlay stuff. CarPlay stuff. Creating buttons. I'm gonna drop a button here, be a voltage sensor. So we built this. We should have the right image now. So I've got battery, monitor, current. It's charging. We got the current. That's voltage charge. This would be voltage. No charge, right? Because you're not charging. It's the same thing here. I gotta log into Twitch. Let's go. Sent the code to my mobile. Alright, remember, yeah. Get in. Right, where's my account? On Twitch. Creator dashboard. There we go. The stream manager. That would be it. Starting, got it. Stream, there we go. I've got a stream. It's running. Alright, so we've got YouTube and Twitch now both running. Let's continue on with our little text thing. Pretty simple stuff. Just doing like the basics here. Voltage, current, charge, battery, monitor. Alright. Oh, what do we got? Oh, okay. It's just this here. La la la. Bum 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 bum. Battery, monitor, current, no charge. Current image. The one that's interesting is this battery monitor status image that we want to do. And this one's going to be a little bit more because we need. What do we need here? We need information. Oh, we've got that information here. There should be a really extension. Images. Extensions will be here. I think we put it in here. We go. Oh. View model. I'll probably turn the music down here so people can actually hear what I'm talking without the music banging on. Plus images. Plus UI images, why not? Because it's just UI images here. Just UNI images. Different status images, right? So I've got this one, this one, this one, this one here. Let's get them all out of here and put them into the extensions. Extension, information, view model. We want import. Have we got core graphics? No, we want UI kit. I think I need to check on something. So I will be back in a minute. All right, back again. Just had to do some things. Oh, and I've got a carrot. Eating it on live on stream. Probably be a lot of the crunchy sounds. All right, let's keep going. So this one here Interesting. Okay. We need to import our driver. Look at this. We also need to import our standard library. Right. Da 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 da. Hey guys, hello. If anybody's there, say hi. I'm just working away. Got a lot to get done this week. I've got to get this finished. And the big thing here is getting the right image for this render. Just a simple image overlay, 2 overlays. So I need to look up Core Graphics probably. Open documentation. How do we convert images? We've got Core Graphics. Well, not Core Graphics, Quartz. So let's go Core Image, right? I think it's Core Image. Use built-in or custom filters to process still and video images. Yep, that's what we want. Core Image is an image processing technology, provides high performance processing of some video images. So basically, I've got 2 images here. Battery monitor. Like, where is it? Here. Oh, we've got more than just 2. We need to do percentage check. Battery level. So let's just do the first one just to get the actual. Let's get the actual algorithm right for rendering it. Pretty simple algorithm. Just take the percentage of the height of the image and then overlay it with the not charged one with the charged. Oh, sorry, the overlay the full one, the empty one with the full one, and cut off the percentage off the top. So yeah, it's been a while since I've done a stream working on it. It's been crazy, very busy. All right, battery. Let's go. Monitor current full. So I want the full image. So let's just see what we want here. We want to get return just an empty image for now. Full image equals that image R is a enumeration library that plugged into Xcode to get you constant values for access to strings, images, and fonts and other things. I think so. We got this green charge, so full image. Okay, and then empty image. This one will be one of 3, so it'll be green, orange, or red. Image. Empty charge. All right. So now what we do is we get the percentage. I think we already have that. Battery 30%, so we don't need that. We've got battery percentage. So what we want to do is get the height of the full image from the battery percentage. Get the percentage of the height. Get the percentage. The height of the full image from the. Okay, so we need first. Obviously, we need the height. And these class full image. Yeah, full image height offset. Probably call it height offset. Yeah, we don't have that. We do just have the UI image. I wonder what else. How would we get a core image from a UI image, a CI image, a representation of an image to be processed or produced by core image filters? Say core image, CI image. Can we convert a UI image Oh yeah, we can. We just initialize it with a UI image. Initialize an UI kit image object. Easy. So I don't think you can get the height values. And then we would want to know image information, dimensions. We can draw. Say we could draw one to the other, right? Come on, where are the dimensions? Properties. CI image. Where do we get the list of CI images? CI image. Come on. And that's it? How do I get that? I've got the properties containing metadata about the image. The rectangle that specifies the extent of the image. Is that the... Well, we can try that, I guess. Extent. The rectangle specifies the extent of the image. This rectangle specifies in the working space coordinates. Filter shape returns a shape. Filter shape object. Interesting. So how do you actually know what? I know you need a context to do context CG image. Core graphics image object that was created from, if applicable. Maybe we need the CG image. So this is actually dated before CI image, isn't it? Or not? CG image. CI image. iOS 5, yeah. So core CG image would be the correct one, not CI image. Can we... How do we initialize it? Bits per pixel, height. Yeah, we've got the width and height. So I take it we get a CG, the full image, CUI image, right? No, it's an image resource. So we need to do this. Oh, silly. All right, okay. So if you've done any Swift programming or iOS dev, you may have run into this stuff. It's been, I think, a long time since I've done any of this. Maybe too many languages. So yeah, I've got another thing I'm doing in what else? In JavaScript. Two other JavaScript projects. One's a web platform. The other one is a website game. Which I'll probably do some work on later tonight after this. Yep, so I'll do that after I finish this image stuff. All right, let's have a look and get this done. It should be pretty straightforward. So we want to go to UI image, and we've got our full image. Let's see, we've got the CG. We don't need a CI image. We've got the CG image. CG core graphics full image equals. Else we return a UI image, empty UI image, right? Okay. We got the CG image, so now we got the image height equals CG dot height. Easy as pie. And now what we want to do is we get the percentage time let image from percentage. Equals image height times 1 over battery percentage. Oh, it's a string. Oh, so that was one of the things I just had before, and I had it as an integer, battery percentage text. I'll call it battery percentage text. Let's refactor that. Battery percentage text. Okay, we've got our battery percentage as a integer value. Oh, we'll just go straight to double, right? We'll just get that. No, let's go. Yep. Version view model. We initialize it here. Where do we get battery percentage text? We got solve battery. Easy battery percentage. 1 over double, and this little value here. We're gonna probably just refactor that. Charge percent, so it's not as charge percent. There we go. Nice and easy. And this one here will go 0. Okay, guys. Let's see. It's been going on for a little while. Just a test of the stream. Seems like a few things happening. Got a few people on. If you are around, do say hello. Otherwise, I'll probably just wrap up and just keep going. Q7. Wrap up. I mean, I'll wrap up the stream, but I'll keep coding. All right. So I've got this image from higher percentage, battery percentage. We don't need that, we can just times it. Yeah, multiply it times it. Binary operator cannot be applied. So we've got the double, and then we'll convert it to yeah, something like that. Because battery percentage is already, 1 over 100, so it'll be the same thing. So we have the height from percentage. Now we need to render a new image. We need to render image overlaying the full image with empty image of overlaying over empty image. So I think we would need to look at interesting. Core graphics. Let's have a look. Core graphics point graphics constants. Quartz display services. So main display. No. Quartz event window services. We don't want to. We want a context. CG context. And we want to. There we go. We want to generate a context. How do we create? CG context represents a Quartz 2D drawing destination. So we draw into it and then we generate an image from it. Creating PDF bitmap graphics contexts. We don't need any of this. We want to add arc, add path, place bound. Can we render, draw, fill path, stroke path? We want to draw an image, draw a CG image in CG Rect by tiling false. So I think, so we'll create context, right? We've got a context equals CG context. Can we create an empty one? No. We do need something. So I guess if we're creating a context to render unsafe with CG context represents two Quartz drawing destination. Graphics context contains drawing parameters and all device specific information needed to render paint on a page to the destination with the destination window in an application, bitmap image or PDF document or printer. So we want a bitmap image, which means that creates a bitmap graphics context. Callback function. We don't need a callback function. PDF graphics context. That's yeah. I guess we'll just use this. Image data. Oh, data. Well, I wonder if we can actually make this context equals Godlet. UI image. What we're doing here, we're going to render an image over another image. Bum, 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 ba-dum, bum. That's context. Here we've got data. Image. Raw, mutable, unsafe, mutable raw pointer. Really? Unsafe. We've got the width, height. We need to create an image. Surely there's got to be a better way to get an image context together. I'm sure I've done something before like this. Let's see. Wait, okay, we've got CG image masking. We just use that instead of doing this crazy stuff. Mask creates a bitmap image from an existing image and an image mask. A mask. If the image mask is image, it must be in the device gray color space, must not have an alpha component, and may not itself be masked. So we don't want it cropping. Creates a bitmap image using the data contained within a subregion of an existing bitmap image. Creating images by modifying. Working with. So. What we could do is we've got the CG image for the empty image, right? So what we can do is we create the context with the data from that and then write to that with the other one, with the full image. Copy, cropping, creates a bitmap image using data contained within this subregion. Okay, so we don't want to create the crop. Creating image masks, working with it. So on move, no, that's not what I'm doing. Down view content, that's not what I want. Let's go back. Boom. This is old school stuff. iOS 2.0. Far out. This is like ancient, but this is what all of this iOS stuff is built on. Everything uses this. Everything from SwiftUI to UIKit. Everything. Every app that you see. All the pictures use this. All right, I'm gonna wrap up for this stream. Thanks for joining in, and I'll catch you again, I guess. Catch you again next time. Get back into this. Thank you. We'll make it a bit longer next time.